Okay, let's look at metric conversions raised to a power. We will do those in a similar fashion as we did the regular metric conversions. In number one, we want to go from cubic centimeters to cubic meters. Now, we would perform this operation much the same as we would in the regular metric conversions. We need to know the conversion factor, the relationship between the centimeter and the meter. So 1 centimeter is equal to 10 to the minus 2 meters. Now, since this is raised to a power, I need to cube both sides. So when I cube this number 1, that's 1 times 1 times 1, I get 1. When I cube a centimeter, that's a centimeter times a centimeter times a centimeter, that gives me the unit of centimeters cubed, or cubic centimeter. Now, on this other side, I have to cube 10 to the minus 2, which is 10 to the minus 2 times 10 to the minus 2 times 10 to the minus 2. Same base, add exponents. That would give me 10 to the minus 6. I need to cube the unit of meter. That would give me meters cubed. Or else, if I use this 10 to the minus 2, I could just multiply the indices of minus 2 and 3 and simply get that negative 6. I just wrote this out so you could see where it all came from. So this is the conversion factor that we need. We can write out 1750 cubic centimeters times 1 cubic centimeter is equal to 10 to the minus 6 meters. My unit of centimeters cancels. So I'm left with 1750 times 10 to the minus 6 cubic meters. Now note that this number is not in scientific notation. It is not in scientific notation because 1750 is not between 1 and 10. So what I need to do is move this decimal place 1, 2, 3 places to the left. So that would give me 1.750 times 10 to the minus 6. I've moved it 3 places to the left, so I need to multiply by 10 to the third for those 3 places. And that would give me, adding like bases, that would give me a answer of 10 to the minus 3, and that would be 1.750 times 10 to the minus 3 meters cubed. Do not forget your unit. Now, we can write out all of these things if we want until you get a hang of it, or we could simply write it out while we're doing the problem. Let's look at the next example. We want to convert in this next example from inches squared to meters squared. So square inches to square meters. Okay, so we will need to know something about how to relate the inch to a meter. We're going from a standard unit of inches to a metric unit. So we can say we know a relationship between the inch and the centimeter, and we know a relationship between the centimeter and a meter. So we would be squaring all of these things in order to get to meters squared. So the conversion factor one inch is equal to 2.54 centimeters. And 1 centimeter is equal to 10 to the minus 2 meters. So we can set this problem up. We don't have to square these units. We can actually square them in the problem. We have 950 inches squared times 1 inch is 2.54 centimeters. So we can come here and actually do the squaring. And the next step, we want to go from centimeters squared. So 1 centimeter is equal to 10 to the minus 2 meters. So we would square here. That would give us our centimeters squared. Now, I can rewrite this out below what we have when we square these things. We have 950 inches squared times. When I square 2.54, I wind up with 6.45. Squaring the unit would give me centimeters squared. When I square 1, I wind up with 1. Squaring the unit, I get inches squared. If I square this numerator, I get 10 to the minus 4. When I square this unit, I get meters squared. Squaring 1, I get 1. And squaring centimeters, I get centimeters squared. So now we can look and see that these units do cancel. And when we do all of this multiplication, we wind up with 0.61275. And I can write that in scientific notation, moving it 1 decimal place to the right, and that would be 6.1275 meters squared. Off something. 6.275 times 10 to the minus 1 meters squared. So that would be the correct answer in scientific notation. Now, let's look at the third problem. Let's just say we wanted a unit in the dimension of cubic nanometers. Let's just say for a factor, just say for instance we wanted that unit. So the process would be the same. We will start out with 450 centimeters cubed. I need to know the relationship between the centimeter, the meter, and the meter, and the nanometer. And I'm going to cube all of those. So in 1 centimeter, I have 10 to the minus 2 meters. I'm going to cube this expression. The next thing I'm going to do is, in 1 nanometer, I have 10 to the minus 9 meters. I'm going to cube this expression. So I can come down below and I can write out what we actually get when we cube these expressions. So I'll rewrite 450 centimeters cubed times cubing this expression. 10 to the minus 2 cubed gives me 10 to the minus 6 meters cubed over 1 centimeter cubed times cubing 1 gives me 1, cubing the unit of nanometer gives me nanometer cubed, cubing 10 to the minus 9, keep in mind that's 10 to the minus 9 times 10 to the minus 9 times 10 to the minus 9. Same base, add exponents, that gives me 10 to the minus 27. Or I can multiply these two indices and say that's 10 raised to the negative 9 times 3 is minus 27. And I need to cube the unit, and that gives me meters cubed. Now I can come here and cancel our units. Cubic centimeters cancel, cubic meter cancels, and I'm left with the desired unit of nanometers cubed. So when I write all of this out, I have 450 times 10 to the minus 6. I want to bring this denominator of 10 to the minus 27 to the numerator, so that becomes 10 to the 27th power in the numerator, all nanometers cubed. I can simplify this expression and say 450 times 10 to the 21st nanometer cubed. This is not in scientific notation because 450 is not between 1 and 10. So what I need to do is move this decimal place 2 places. So what I wind up with is 4.50 times 10 to the 21st times 10 squared. For those 2 places that I moved the decimal to the left. So that winds up being 4.50 times 10 to the 23rd nanometers cubed. So I write out all these steps so you can see exactly what's going on. You may not have to write out details such as this and details such as this to arrive at your final answer. But I do want to see these details when you work these type problems on your exam.